Hello, welcome to my video on insertion sort, where we talk about insertion sort. Yeah, that's all I have to say about that. So, want to know what insertion sort is? Well, you should probably know what sorting is, which, if you don't already know, is just taking a list of values and putting it from largest to smallest, or smallest to largest if you want to be bold. And in Java, if you're going to do sorting, there's different ways you can do it, and some are more efficient than others, but it really comes down to what your program needs to do to determine which one you want to choose. So insertion sort is basically taking the value that you're currently on, which you tend to start at 0, but, you know, be a rebel, start at 5, I don't care. And you compare it to the value to the right. And if that value is greater than the current value, you swap it behind you. Kind of like what you do with a deck of cards. And some of the benefits to using insertion sort is that it's really simple to implement. It's kind of abstract if you're new to programming, but when you get down to different types of sorting, it's generally the easiest to do. And it's really efficient on small data values, nothing too large, details. It is much more efficient on data that's already sorted, but that's obvious. Now, when we talk about a sorting algorithm's efficiency, we use big O notation, which basically just tells you its efficiency in time. So when you say big O of n, where n is the efficiency of the program, when you say O of n, you say the running time will be no worse than whatever is in the parentheses around n. So O is its efficiency is going to be no worse than n. Insertion sort has an efficiency of big O to n squared on average sorting. But at best it can be big O n. And basically that means that's the best it can be. But that's only in optimal conditions, like if it's already sorted and you have a lot of free memory and processing power, but even still, that's if you're lucky. And here's a list of the efficiency of all the different types of sorting. You can read through that if you want, but I'm not going to go over it. And this is what it looks like in Java if you were to make a method for it. So basically what you have is you can use virtually any data type to sort, but most people tend to stick to strings and integers, and for this example it's a string. So when you say, for example, say you have a list of strings and you were to say in a for loop that runs from 1 or 0 to the end and increments, basically that just goes through the whole list. You have an inner for loop that will run from the position of I until it reaches 0. So basically what this was saying is if the value at the left is less than or compared to greater than 0 than the value to the right, then it'll take that value and basically swap them until that value is less than the value to the right and greater than the value to the left. Otherwise, it'll just move on to the next value. And here's a more visual representation of how it would work. Was had him, and you his at the butt. Now I can show you a program in actually working. So this is my method, insertion sort, whatever. It takes an array of ints, and it runs through the list. Basically what this for loop does is it'll keep running while the current value is less than the value to the right. So it'll keep pushing the smaller value up the list. Then it'll put the value in the right location. And if you were to run that, which I already did, this is what the list first looked like, and this is what it looks like after. Yeah. So yeah, I'll leave you with a video spin build.
No, be assertive! Great! Now let him have it!